Hello class, today we're on 6.7 Exponential Word Problems Part 2, and these exponential word problems are going to be interest problems. So we're talking about money and compound interest. So when dealing with compound interest, we have this function right here, a equals p times 1 plus r over n times n to the t, where p is our principal amount or our initial amount, how much we start out with. R is our annual interest rate, and that's as a decimal. And when I say decimal, I don't mean percentage, right? Because if you look down here, we're given percentage, so we'll have to convert it to a decimal. N is the number of times interest is compounded in a year. So when I say compounded in a year, I mean how many times is that interest being applied per year? And then T is just our number of years. That's our input. So what we're going to do is we're going to plug in all the values in here and then solve how we've been solving for these word problems like we did yesterday. And again, I understand that many of you don't have calculators that are powerful enough to do these logs with different bases. So just as long as you give me the formula, I'll be fine, okay? Or not the formula, but as long as you give me the formula where it's solved for the variable, that's fine. Okay, so let's take a look at this initial example. An initial amount of money is invested at a rate of 5% compounded monthly. Determine the balance after 4 years if the initial amount is $2,500. So first, let's identify our P, R, and N. So P is going to be our initial amount. Oh, well, then here, determine the balance after 4 years if the initial amount is $2,500. So the initial amount is $2,500. Our R is our annual interest rate as a decimal. Now, do you remember how to get percentages to decimals? Well, if we have a percentage here, we just move the decimal spot 2 places to the left. So 1, 2. So it's really 0.05. You can think about it as moving the decimal place over to the left or divide it by 100. Either way will get you the same thing. So our R is 0.05. Think of cents, right? What's 5% of a dollar? 5 cents, right? And then N is the number of times the interest is compounded in a year. Well, this is compounded monthly, so that's going to be 12 times a year. There are 12 months, right, in a year. And then T is just years. T will always be years in this case, or in these kinds of problems. So determine the balance after 4 years if the initial amount is $2,500. Well, we just plug it into a formula. So A is equal to $2,500 times 1 plus R over N. So 1 plus R, which is 0.05 over 12 to the NT power, or the 12T power. Awesome. So this is our function. This isn't actually the answer to this problem. Determine the balance after 4 years if the initial amount is $2,500. Well, just like our last ones, 4 years, that's a T value, so let's just plug in 4 in for T. And we would plug into our calculator and see what the value is. So A equals 2,500 times 1 plus 0.05 over 12 to the 12 times 4 power. Now I'm going to go ahead and plug that into my calculator here. Like I said, I understand a lot of you don't have these calculators. So if that's the case, this will be an okay answer for me, as long as you just plug in the value, okay? And we get 3,052 point, and we're talking about money, so let's round to a good decimal place, the hundredths place, right? We're talking about money, so 0.24. So that would be a dollar amount, so it'd be $3,052.24. So that would be the balance. That's how much is in the account after 4 years. What about the second one? How many years will it take for the balance to go above 3,500? So basically it's asking how long will it take for the balance to be 3,500? Well, that would be an A value. We want to know when our function when is our function going to equal 3,500? So I'm going to set my function equal to 3,500. And solve for t. So I want to know the time when it equals 3,500 or above. So here I'm going to divide both sides by 2,500. I believe that's 7/5. Let's see. Just want to make sure. Yeah, 1.4. We can do 1.4. That's fine. But yeah, I think that would be 7/5. So equals 1 plus 0.05 over 12 to the 12t power. Now that we have the base by itself, this might be a good idea. I know all of your calculators are able to do this. Let's simplify this in here so it just looks a little nicer. So what we want to do is we want to take 0.05 divided by 12 and then add 1 to it. So 0.05 divided by 12 plus 1. And we get 1.0042. Let's round to the 4th decimal place. So I can rewrite this as 1.4 equals 1.0042 to the 12t power. Now, look at the base is by itself. Well, the base is by itself up here too, but it's by itself down here. So let's convert these forms. So remember, if we have b to the x is equal to a, we can write it as log base b, which is 1.0042 of a, 1.4, is equal to our exponent 12t. And then, of course, we want to get t by itself, so let's divide both sides by 12. This will cancel. So t is equal to log base 1.0042 of 1.4 divided by 12. And that's that. So let's go on to another example. The initial amount of money is invested at a rate. An initial amount of money is invested at a rate of 10% compounded quarterly, or quarterly means 4 times a year. Determine the balance after 7 years if the initial amount is 5,000, and how many years will it take for the balance to go above 7,000? So let's first define our A, R, and T. Where am I going to do this? Let's do it over here. So A, or no, not A, R, and T. I was thinking about yesterday. P is our principal. That's going to be 5,000. Our R is our interest rate as a decimal. So we have 10%. Move the decimal spot 2 places to the left. We get 0.1. So R is 0.1. Or you can think of 0.10, right? And then N is how many times it's compounded a year, and that's quarterly, so 4 times a year. And we're good. We can plug it into our formula. So A is equal to 5,000 times 1 plus 0.10 over 4 to the 4t power. Awesome. And then let's see here. So determine the balance after 7 years. Well, we're just going to plug in 7 for t. So A is equal to 5,000. 1 plus, I always do that, 1 plus 0.10 over 4 to the 4 times 7th power. And again, if you don't have calculators, I'm fine just leaving it like this. But I have a calculator, so let's just kind of go see for fun what this is. So 1 plus 0.1 divided by 4 to the 4 times 7 is what, 28? 28th power. So after 7 years, the balance is going to be $9,982.48. Awesome. Then how long will it take for the balance to go above 7,000? Well, again, we're going to set our equation equal to 7,000. So I have 7,000 equals 5,000 times 1 plus 0.1 over 4 to the 4t power. And I want to leave t in here when I do this because I'm solving for t, right? I don't want to I'm not plugging in 7 anymore. So now let's get the base by itself. So we're dividing both sides by 5,000. That cancels. 7,000 divided by 5. Is that 1.4 again? Yeah, it is. Look at that. Okay. So let's see here. So 1.4 is equal to 1 plus 0.1 over 4 to the 4t power. And let's see. Let's clean up this little thing, this little bit in the middle here. So again, I'm going to take 0.1, divide it by 4, and add 1 to it. And that's 1.025. So 1.4 equals 1.025 to the 4t power. And then now we can convert it into log form. So we have log base of 1.025 of 1.4 is equal to 4t. And then divide both sides by 4. So t is equal to log base 1.025 of 1.4 divided by 4. And I just realized with neither of these, I didn't plug in either of these into the calculator. So let's go ahead and do that just for fun. So going back to this one, how long will it take for that 2,500 to get 3,500? Let's see. $6.69 years. Awesome. And then over here, log base 1.025 of 1.4 again, divided by 4. And this will take 3.407 years. Awesome. All right, I got 2 more examples for us. An initial amount of money is invested at a rate of 3% compounded annually once a year. That's what annually is, right? So determine the balance after 10 years if the initial amount is 6,500, and how many years will it take for the balance to go above 8,500? So let's define our P, define our R, and our N. So P is the initial value, so that's 6,500. R is our percentage, but as a decimal, so that'd be 0.03. And then N is how many times it is compounded a year. Well, that's annually, so that's once a year. So N is going to be 1. So our function here, A is equal to 6,500 times 1 plus 0.03 over 1 to the 1t power, or just to the t power. And then determine the balance after 10 years. Well, we just plug in 10 for t. So A is equal to 6,500 times 1 plus 0.03 over 1 to the 10th power. And again, you could leave it like that, but I'm going to go ahead and figure that out. And we get 8,735, and we're talking about money, so $0.46. So that'll be the balance in 10 years. So how many years will it take for the balance to go above 8,500? Well, we know it's going to be less than 10 years, because in 10 years we'll have 8,700. So let's make a guess, maybe like 8 or 9 years? Let's see. So we're going to set our equation equal to 8,500. And again, I want t in there. I'm not plugging in 10 anymore. And then so we divide both sides by 6,500. And let's see, we get I'm just going to round this, 1.308 is equal to, this cancels, 1 plus 0.03 over 1 to the t power. We can go ahead and clean this up. This is pretty easy math right here. 0.03 divided by 1 is just 0.03. 0.03 plus 1 is 0.03. So 1.308 equals 1.03 to the t power. And then we can convert it. So log base 1.03 of 1.308 is equal to t. And we can go ahead and plug it in. This is a fine answer for you if you don't have a calculator. but let's just kind of see. I'm curious here. $9.08 years. Nice. So t equals 9.08 years. Awesome. And one last example. Excuse me. So an initial amount of money is invested at a rate of 8% compounded biannually, so twice a year. Determine the balance after 1 year if the initial amount is 1,000, and how many years will it take for the balance to go above 1,500? So again, let's define our P, R, and N. So P is the principal, so that's going to be our initial amount of 1,000. N, or R, is going to be 8, but we need to turn it into a decimal, so it's going to be 0.08. And then N is how many times? Twice a year, so N is 2. So our function is going to be A equals 1,000 times 1 plus 0.08 over 2 to the 2t power. Turning the balance after 1 year, we're just plugging in 1 for t, so that would just be A equals 1,000 times 1 plus 0.08 over 2 to the 2 times 1 power, or just to the second power, just like that. And let's figure out what that is since I have my calculator. So 1,000, 1 plus 0.08 divided by 2 to the second power, we get 1,081.6. So that would be the value, the dollar value, after 1 year. All right, then how many years will it take for the balance to go above 1,500? I'm going to take my function, set it equal to 1,500. Again, leaving t in there, and then I'm going to solve for t. So I'm going to divide both sides by 1,000 in order to get my base by itself. This is going to be 1.5 is equal to 1 plus 0.808, over 2 to the 2t power. Then we can clean up the middle here. This isn't bad math either. 0.08 divided by 2 is 0.04, plus 1, 1.04 to the 2t power. And then we convert. So this will turn to log base 1.04 of 1.5 is equal to 2t. And then go ahead and divide both sides by 2. So t is equal to log base 1.04 of 1.5 all over 2. And again, this answer is acceptable, but let's see, just for fun, because this is fun stuff. And we get 5.16 years. Or 5.17, I guess. We round it. Awesome. So that is all I have for y'all today. Hopefully we're feeling pretty good about this. So go ahead and try the worksheet. Let me know if you have any questions.